Next is we have to consider about the next example. Find radius of convergence and interval of convergence. Okay, we have to look through the problems, right? Uh, Find the radius of convergence and interval of convergence of summation n equal to 1 to infinity x raised to n by n. Okay, so we have to consider take this u1 as equal to x raised to n by n. Okay, in the alternating series, we have considered only the term except this minus 1 power, right? Here we have to consider in the power series form. So in the case of the question, in order to find out the radius of convergence and interval of convergence, we need to consider this as a total. We have to take the total function as un equal to x raised to n divided by n. X raised to n divided by n is equal to un. Next we have to take the limit. Limit is equal to limit n tends to infinity mod un plus 1 divided by un, which is equal to limit n tends to infinity mod x raised to n plus 1 divided by n plus 1 divided by divided by un is equal to x raised to n divided by n. Okay, so here after clearing these, after substituting and some rearrangements will be happened here, and after that we will get a limit n tends to infinity n divided by n plus 1 into mod x. Okay, so letting n tends to infinity in this, we will get the answer is mod x. Okay, what was our ratio test? In the ratio test we will say that the ratio test converges if the result is less than 1. Okay, so here the result, if the result is less than 1, this is convergent, and the result means mod x is less than 1, the series converges. Okay, so mod x less than 1 means that is minus 1 less than x less than 1, right? So we have the radius of convergence is equal to of the series is equal to what? This is equal to 1. Mod x is less than 1. Mod x is less than 1. That is r is equal to 1. To determine the interval of convergence, of the power series, we have to examine the behavior of the series at the end points also. Okay, so here we have to look through the endpoints. At x is equal to 1, what happened to the series? At x equal to 1, the series will become, consider this question, summation 1 by n. We know that the series diverges, right? And put x equal to minus 1, then this will become minus n divided by n. Look at here. Okay, we know that this is alternating series. By using that test, we can say the Leibniz test, we can say that the series converges. So in the interval minus 1 closed, 1 open, in this interval the series convergence, and this is the interval of convergence, and the radius of convergence is equal to 1. Okay, here only the result comes as 0. So this is the convergence happens at for all values of x. Okay, here a particular values of x, that is the difference between the previous problem and this problem. It is very important, very important actually. Okay, right. Next. Consider the next question. Find the radius of convergence and interval of convergence of summation n equal to 1 to infinity x minus 2 whole power n divided by n square into 3 raised to n. Okay, letting u1 is equal to, consider total we have to take as u1. Consider mod u1 plus 1 by u1. After some calculation, we will get this. This will be the limit. And what will be the value of n by n plus 1? This is equal to mod x minus 2 divided by 3. Okay, and we know that by ratio test, if the series less than, and if the value is less than 1, we can say that the series converges, otherwise it diverges, right? So this converges if mod x minus 2 by 3 is less than 1, or mod x minus 2 is less than 1. After redefining this as here, the radius of convergence is, look at here, that is 3, right? And the power series mod x minus 2 is less than 3 means minus 3 less than x minus 2 less than 3. Adding 2 on both sides, so we will get this interval is minus 1 to 5. Next, we have to check at the end points. What will be the behavior of the convergence at the end points, right? Put x is equal to minus 1 and put x is equal to 5 here. X is equal to 5. So what will happen to our question? Put x is equal to minus 1. Then this will become minus 3 whole power n divided by n square divided by n square into 3 raised to n. 3 raised to n, I can take this as outside, and this will become minus 1 power n into 3 raised to n. This 3 raised to n will get cancelled, and finally we will get the answer. The series will be of the form minus 1 power n divided by n square. By using the Leibniz test, alternating series test, we can check the convergence. Okay. And we know that the series is convergent because here n is equal to 1 by n square, and we can say that this n is a decreasing sequence and the limit is equal to 0. So by alternating series test, the series converges, right? Next is put x is equal to minus x is equal to 1 here, sorry 5 here. So 5 minus 2, that will be 3 raised to n, and that will be of the form 1 sigma 1 by n square. Clearly we can say that by p-test the series converges. So in the closed minus 1 and at that point minus 1 and 5, the series converges. So the series converges in the closed interval minus 1 to 5. Okay, look at the next example. Find radius of convergence of interval convergence of this. Put u1 is equal to the whole value except inside this series term. u1 take n plus 1 divided by u1. This will be of this type. So n taking outside on 1 plus 1 by n, 1 plus 2 by n. This n will get cancelled, and 2 into mod x into this value will be 1. So answer will be 2 into mod x. And we know that the values, if the value is less than 1, the series converges. So 2 into mod x is less than 1, the series converges. So mod x is strictly less than 1 by 2. Okay, so our radius of convergence is 1 by 2. Right, so the series converges in the interval minus 1 by 2 to 1 by 2. Okay, so next what we have to check? We have to check the convergence or behavior of a series at the end point. So put x is equal to minus 1 by 2 in the question. The question will be of the form x is equal to minus 1 by 2, minus 1 by 2 whole power n. Then minus 1 whole power n divided by 2 raised to n. As 2 raised to n will get cancelled, and the remaining term will be of the form minus 1 power n into minus 1 power n. That will become minus 1 power 2 1. That will be positive. This will be a positive term series, summation n equal to 0 to infinity 1 by root n plus 1. Okay. By using the limit comparison test, we can say that the series this series is divergent because by using the p-test comparison, p series 1 by n root n, we can test with a root test. Okay. Next is put x is equal to 1 by 2. Put x is equal to 1 by 2. We have this is equal to x is equal to 1 by 2. Then the series will be of the form minus 1 power n divided by root n plus 1. And by alternating series test, we can say that the series converges. Okay. So this is the interval of convergences. My open interval minus 1 by 2. This is very important. The interval is closed or open. Okay, that is we have to check that. Okay, so next is differentiation and integration of the power series. Differentiation and integration of the power series, and this is a power series. F of x is equal to the summation a n into x minus c whole power n. This is a power series. Okay, differentiation and integration of the power series. Suppose that the power series has a radius of convergence r is greater than 0. Then the function f is defined by this is a function for all x in this interval and is both differentiable and integrable on this interval. Okay. Moreover, the derivative of f and infinity integral are defined as f dash x is defined as just differentiate all these series. Then this will become a1 into 2 into a2 into x minus e plus etc. Right? And this can be written like this. Okay, this can be some like the series as a summation n equal to 1 to infinity n a n into x minus c whole power n minus 1. And what will be the integral? What will be the integral? What will be the integral? Integral f of x dx is equal to c plus that's a constant a naught into x minus c plus a1 into x minus c whole square divided by 2 plus a2 into x minus c whole raised to n minus 1 plus etc. And this can be summed as a summation a n into x minus c whole power n plus 1 divided by n plus 1 plus c. This is the integration. This is integration. And the next is example. Find a power series representation of the for 1 by 1 minus x square x whole square on minus 1 1 by differentiating power series representation f of x is equal to 1 by 1 minus x. Okay, recalling that 1 by 1 minus x, 1 by 1 minus x can be written as this is a geometric series and the series of this type if mod x is strictly less than 1. Right, and I can define this derivative as 1 plus 2x plus 3x square plus etc. And the summation is this one. And using this, we can say that this is the f dash x. Okay. Fine, this is a power series f of x equal to 1 by 1 minus x. By using this power series, this is the series type, this series form, and we know that the derivative of 1 by 1 minus x is equal to 1 by 1 minus x whole square. Okay. Next example is equal to find a power series representation for log 1 minus x on minus 1 to 1. We start with the equation 1 by 1 minus x is equal to this one. This is integrating. This one is equal to. Okay, we can check in the we can look through this example in the next video. Okay, thank you.